In week 1, we briefly looked at the ERD feature in pgadmin and learned about crow's foot notation. ERDs with crow's foot notation are a worldwide standard for how to visually represent the relationships between tables in a database. Now, if you haven't worked with a relational database before, the complexity can be confusing at first. We know that our DVD rental database has 15 tables in it. If we ignore our database diagram for a moment and instead just look at the list of tables in pgadmin, it's not totally clear which tables relate to each other and how. For instance, we have a film table, an actor table, and a film actor table. These 3 tables are related to each other, and you might have guessed that already just based on how they are named, but it's not immediately clear that a relationship exists. One way we can make sure is to look at the constraints on each table. Constraints are rules that we can enforce on the data in a SQL table. In our week 1 videos, remember that we discussed primary keys, which are the columns that uniquely identify each row in a given table, like the actor ID column in our actor table. Primary keys are one type of constraint in relational database design because in order to uniquely identify each row in a table, the primary key itself must have unique values. These are the kinds of rules we're talking about when we talk about constraints. Another example of a constraint is the default constraint, which allows us to set the default value for a particular column in a table. Thinking of our actor table, we could hypothetically put a default constraint on the first name column, which says the default first name should always be John. And we could put another default constraint on the last name column, saying the default last name should always be Smith. We can then override the default value when we insert data into the table by specifying the precise values we want to insert, like we could say, insert Chris Pratt. But if we don't specify the precise value we want to insert, the default constraints on those columns will enforce their rules, and we will insert John Smith instead. Other than the primary key constraint, the most important type of constraint you will encounter in a relational database is a foreign key constraint. A foreign key is a column or set of columns that creates a relationship between 2 tables, linking them together. Foreign keys are also sometimes called references. The foreign key constraint, then, is a rule in our database that explicitly says these 2 tables are related to each other using this column or set of columns. To illustrate this, let's look at the film actor table in pgadmin. If we expand the constraints under our table name, we see 3 of them listed. One has a gold key icon next to it and is suffixed with pkey, which tells us that this is our primary key constraint. The other 2 have silver key icons next to them and are suffixed with fkey, which tells us that these are our foreign key constraints. Let's take a closer look at these constraints by right-clicking on our film actor table, then find Scripts and select Create Script. This will open a new tab in pgadmin that displays the code that is used to build our film actor table. For now, I want you to ignore everything except the 3 lines that begin with constraint. These are the SQL code that creates each constraint on our table. Each line of code starts by first declaring that we're about to create a constraint, and then it names the constraint. Next, it declares the type of constraint we are creating, and in parentheses, it lists the column on this table that are used to create the constraint. You can tell that the first constraint creates our primary key because it says primary key. Notice that inside the parentheses, it lists both the actor ID and film ID columns. Any key on a database table, whether it is a primary key or a foreign key, can consist of one or multiple columns. When a key is composed of multiple columns, it is referred to as a composite key. In this case, our primary key, which is the key that uniquely identifies each row in our table, is a composite key that consists of both the actor ID and film ID columns on the film actor table. Now, let's look at the code that creates our 2 foreign key constraints. The first one says we are creating a foreign key using the actor ID column on the film actor table. Then, on the next line, it specifies which table and column we are referencing. This is the key thing I want you to notice about each foreign key constraint. First, we list the actor table, which resides in our public schema, and then inside parentheses, we specify the actor ID column on the actor table. So, when we put all this together, it says we are creating a foreign key constraint on the film actor table using the actor ID column, which references the actor ID column on the actor table. And the third constraint, which is our second foreign key constraint, says the exact same thing, but it says it for the film table instead, using the film ID column. We have two foreign keys on the film actor table, and these foreign key constraints create rules on that table. In effect, what these foreign key rules are saying is a row cannot exist in the film actor table unless the actor ID exists in the actor table and the film ID exists in the film table. Keep in mind, the purpose of the film actor table is to create a relationship between the actor table and the film table. Practically speaking, this table allows us to say, here is a film, and these are the actors who starred in that film. So the foreign key constraints on this table help us by preventing us from adding invalid data. The rule in effect here says that we cannot add actors to a film unless first we have database records for both the actors and the film. Ultimately, foreign key constraints help maintain the integrity of our database. For example, if we tried to delete an actor from our actor table, Postgres would return an error saying, you can't delete this data because it is referenced by a foreign key constraint. In order to delete the record from the actor table, we first need to delete all the records that reference that actor ID in the film actor table. So, the database is using the foreign key constraints to prevent us from destroying valuable data that creates a link between two tables. That doesn't stop us from deleting data necessarily, but it means we need to think very carefully about how to delete our data if a situation ever requires us to do so. Another key term to remember here is referential integrity, which is a vital aspect of database design. Referential integrity is a concept that refers to the accuracy and validity of the data that defines the relationships between our tables. Foreign key constraints are a crucial component in maintaining referential integrity in a database and ensuring that we don't break any of our table relationships. By establishing rules on our tables that say this data can only exist here when it also exists in other tables, the foreign key constraints ensure that the data is valid and that we maintain referential integrity on the database. If our database lacks referential integrity because we failed to establish foreign key relationships, we will end up with what are called orphaned records. Orphaned records are rows with a foreign key pointing to a record that no longer exists in another table. For example, if we didn't have any foreign keys on the film actor table and then we deleted the actor Woody Hoffman from our actor table, then all of the records in the film actor table that referenced Woody Hoffman would now be orphaned. They would be pointing to an actor ID that no longer exists. This would compromise the accuracy of our data and the integrity of our database. So it's important to avoid situations that lead to orphaned records. And this is why foreign keys and foreign key constraints exist. Use the additional reading below this video to learn more about create table scripts in SQL, as well as primary keys and foreign keys. In the next video, we're going to continue exploring the concepts behind table relationships and talk about the different kinds of joins that are possible when joining two tables together in SQL.